Okay, I want you to pause the video and see if you can give this a go yourself first. What I'm wanting you to do is recognize any patterns from here that exist in here. Okay, so I'm hoping you can give that a go yourself. What I'm going to do is, with a different color, I'm going to do what I see as a pattern. What we have is A and B with a knot over it, and I can see that here. Have a look at this. We've got a knot over A and B. Because we've got a knot over A and B, I'm going to use what's called De Morgan's law, and what I'm simply going to do is put in what not A and B, the equivalent, which is now going to be this. So I'm going to turn this into this. Watch. I'm going to put an AND in, because, sorry, an OR gate in. And then I'm going to do not A, and I'm also going to do not B. But these knots were already in there already. That's what we started with. We started off with two knots and a knot overall. So what I also need to do is have another knot on top, because what De Morgan's law does is it takes this and it simply chops it up. So it takes that line, chops it up. Did I say and? I meant line. And we get the AND gate. Ah, let's try that again. Boom, boom. A dot B. Well, sorry, it's not all. So we've taken this and we've turned it into this. That's step one. Now what I'm going to do is have a look again at what we've got. We've got two NOT gates for A. So we've basically got A, a NOT gate, and then a NOT gate again. So if we were to put 0 through this, it'll turn to 1, then it turns it to 0 again. That basically means it's pointless us having two NOT gates in a row. So what we're going to use is something called double negation. And I'm simply going to just get rid of the two NOT gates. They're gone. Hey presto, they are gone. Let's look at B. We've got the same, we've got two NOT gates for B. So I'm going to get rid of those, double negation. And there we have it. We've now simplified our circuit to be A or B. We are saying that A or B is the same as if we were to put something through a logic gate. So let's draw this out. If I have A and I have B, and I'm using one gate, that should be the same as if we were to do this, which would be A, B, not, and then NAND. So if we were to do 1, 0, and it was to go through here, we know that this is going to be a 0, we know that's going to be a 1, 1 NAND 0 gives us 1. So in our truth table, we would have, for the bottom gate, so let's do it like this: 1, 0, 1 for the bottom gate. Now let's do it for the top gate. I'm going to do it in a different color, or top circuit, shall I say? 1, 0. We know it's an OR gate, so 1, 0 also gives you a 1. If we're to do 1, 1, turns into a 0, turns into a 0, 0 NAND 0 gives you 1. So 1, 1 gives you 1. Let's try it on the OR. Well, we know 1, 1 gives you an OR, so it gives you a 1 on an OR gate. So let's try 0, 0, 0, 0, 0 on an OR gate. 0, 0 gives you a 0. On this circuit, 0 traces through to here, 1 traces through here, 1 and 1 gives you a 0. So my point being is this circuit, which if you look, it's got quite a few gates, can be simplified into this. The way we did that is we used De Morgan's law. What do I mean by De Morgan's law? Well, we look for the pattern, we can see that it had a not over both gates, which meant that we split it, we put them into separated by an or instead, because that's what it tells us to do here. We also keep the the original knots as well, so you can see here the original knot. We then use double negation, so a knot and a knot, there's no point having it, so it cancels each other out, which leaves us with that as our simplified circuit. Let's try another. Okie dokie, so pause the video, see if you can see any patterns within this. Okay, so I'm going to start off with this. I'm going to look at all my laws. What is B1? Or do we have something which is 1B? Remember, B can be replaced with A, so really 1A. Or should I say 1 or A rather than B1. So I'm going to go to the OR column, and we've got 1 or A equals 1. That is a law. So what I'm going to do is I'm going to do a 1 here. That's my step 1. I've used no law to get it to there. But now what? We've now got A and 1. So what would be A and 1? So I'm now going to go to the AND column. Do we have anything which is A1 or 1A? Yes, I do. Identity law. 1A or A1 equals A. And we are done. We have simplified this to its most basic form, so it can still be functional in the same way, and we are left with A. Okay, so I've just seen the weather warnings and I think I might have to evacuate, but let's do this first, this is more important. Okay, so let's have a look at this and see if we've got any laws we could be using. Well, let's look at this one to begin with. That looks familiar. A and B, not. De Morgan's law, happy days. So A or not B or. And notice what I'm going to be doing. I'm not going to solve this one yet. I'm just going to draw it out again. So not B. There you go. Now I'm going to try and solve this side. Again, by looking at this, we could be using De Morgan's law. So I'm going to do De Morgan's law in here, but this is going to be the reverse. We're going to turn it to an AND. So I don't need brackets anymore. It's going to be not A and double not B because of this line here. Now we're going to use double negation on this one. So I'm going to do A, not B, or not A, B like that. This is now where it's going to get a little bit tricky, so I'm hoping you're going to understand what I'm going to be doing. What I am going to do is I'm going to simply move some things around. So the next thing we're going to do when we move things around is I'm going to look to see if there's any common patterns between our terms. So we've got not A over here, we've got a not B over here. I'm going to do them in different colors. We've also got another not A over here, and we've got a B over here. So based on this, we do have a common term, not A, not A. So what I can do is if I go to my laws, if we've got a not A or a not A, we have an A. Sorry, and even. We have an A. So I'm going to replace this with an A. It meets our laws, our rules. Now I'm going to make this not A still. So we can see it, this rule here. I'm then going to, very simply, use OR. I'm going to group the B's together. So we've got not B, and that is going to be with OR B. If we go to our rules, or laws shall I say, do we have a not B or B? Let's go to that not. Yes, we do. Here. Inverse law. Even though we're using B and there's A here, it means the same. So we're going to be left with not A or 1. So what we have here, if we go to our laws, the no law, which is, in this situation, 1 plus A equals 1. So in this situation, not A plus 1, or not A or 1, equals 1. And there we go. Okie dokie, pause the video, give this a go yourself first. You should get excited when you see this because you should straight away see some patterns. Let's have a look at this to start off with. We know we're using De Morgan's law. So I'm going to do that, and I'm then going to do OR. Let's leave this line above as well. And let's now do De Morgan's law. So for this, it's going to be, we need to turn it to an AND, so it's going to be not A, or even not B. Okay. This is not part of it. Button, get rid of this blue line. So there you go. Okay. Next thing we can do is we can use double negation. So for this part of the line and for this gate, they cancel each other out. So we're going to have A, or for this line and this line, they cancel each other out. A, or for this line and this line, they cancel each other out. Very nice. But we're not done yet. So we've got to look at the laws again. What pattern can we have? Well, we've got an A here, and we've got an A here. AA equals A. A or B. And we can't go any further than that. A or B. Pause the video, give this a go yourself first. By the way, this is a not. Just making it out better. So let's make this really thin. There you go. That's kind of good. Okay, straight away, I can see this. We can use De Morgan's law, and I'm going to do double negation at the same time. So we're going to be left with LB, and we're going to have AB, like that. Didn't put in brackets, but the point being is they're grouped together. Now what? Well, okay, we're left with something whereby we've got a not B here, and we've got a B here. What can we do with this? If we go to our laws, we can use the inverse law. So it's almost as if we're going to move this over here to do the inverse law, which will give us 0 dot A. Or should I say and A. Again, if we now look at our laws, we've got the null law. 0 and A equals 0, and that is what we're left with. Pause the video, give this a go yourself first. Okay, this isn't as easy as what we've done previously, because we're going to introduce the distributive law now. The way this is going to work is that we've got this, which is outside of brackets. We've then got B, which is inside of brackets. And we've got C. Yes, I know this says A, but I'm pointing out it's a different variable. And if we're going to use distributive, we're going to take this AB and attach it to A, and we're going to take this AB and attach it to C. And we'll remove the brackets, so it's going to look like this. So in this situation, we took the A and made it ABC, so AB, and then we took the A and made it C, so we've got AB, AC, same with what we've done here. Now what we're going to do is we're going to use this law here. So a hidden step I can do is rearrange this. So we've got A, B, or A, B, C by using this law first. But now we've done that, A is A. So A, B, or A, B, C. Now what? If we look at our laws, do we have anything which represents this as well as this? And we do. It's the absorption law. So this would be our A, or this would be our AB. So we've got these two, which is the same, which is our A. We've got, that's our A again, and this would be our B, which would just give us in itself A, and A would be our AB. And that's as far as we can go with our simplifying. Let me just get rid of this. So by using absorption, so step one, we used distributive. I then rearranged it using commutative. I then got rid of the two A's by using idempotent. I then used absorption to get us there. Pause the video, give us a question to go self first. Okay, so by looking at this, what can we do in this situation? Well, we can identify the common terms. We've got X here, and we've got X here. There are common terms. So what I'm going to do is I'm going to use distributive law. So I'm going to take these common terms and I'm going to simplify it to be just simply X. And then I'm going to group the Y's together. So we now got Y or not Y. And I recognize to do distributive law by if you look at this in itself, we've got, this would be our X, this would be our Y, this would be our X, and this is not Y, which would be C. And we can just simply turn it into this, which is X or etc, etc, but we did it really on this side. So it's the same as doing that. But we're not done. So when we're using excuse me, when we did this distributive law, and I group them together, I actually have to turn this into an AND now instead of an OR. So by me grouping them together, X, Y, now it's going to have to be getting rid of that, putting this over here and turning it into an AND. Then we're going to have this as our next law, which is inverse. When you've got Y and not Y, it gives us 0. So that leaves us with X as our most simplified version. Pause the video, give us a go yourself first. Okay, so we've got A, B, not C, or A and not C. Step one, I'm going to look for our value patterns in here. Not really, but I can see there's common term A, not C, not C. So these are common terms. So what I'm going to do is I'm going to factor them out together. So we're going to have A and not C, and we get B. Now when I factor these out, this is left with A and not C. Moving these to A and not C, it leaves us with 1. So basically by me factoring these out, we would have used the inverse law, which would leave us with B or 1 during the factoring out process. So we now got A and not C and 1. So A, not C, 1, just like that. Oops, but I'm not done. One multiplied by C, or not C, it's just going to remove the value. So we're left with A and not C. Pause the video, give this a go yourself first. Okay, so looking at this, we can see a pattern straight away. We've got, we can use De Morgan's law. We can also use double negation. So let's use De Morgan's law first. By taking this, using De Morgan's law, we're going to have this as our next step. Now let's use double negation. This should be just 1 line, but it looks like it's 2. There you go. Okay. Now, what I'm going to do is very simple. So if I look at now our different laws, I could use the associative law, where we just regroup. So instead of this being A or B or not B, what we can do is have it as A or B or not B, like that. B or B or not B. B or not B equals 1. So we have A or 1. A or 1 gives us 1. So that is our simplified expression. Okay, this one's slightly more challenging. In fact, it's quite a bit more challenging. Just think, sometimes we have to go bigger in order to go smaller. Pause the video, give it a go yourself first. Okay, by looking at this, I actually can't do anything with this at the moment. The only thing I can do is expand. So let me show you what I mean. I'm going to have a not A, a not B, a not C, a not D, or so far nothing is different, but what I'm going to do is introduce, but what I could do is make a sacrifice to make this bigger to help us in the next step. And what I'm going to do is I'm going to duplicate this first term. This actually makes no difference to the end result by doing this. So it's not going to change how the circuit works. But what I can do now is the following. I'm going to look for common terms. So we've got, let's do not A, not B, not A, not B, not A, not B, not A, not B, and not A, not B. And let's put them not A and not B. I'm going to factorize them out. So by doing this, we're going to be left with not C and not D, so that one. Or on this side, not C and D, or C and D, or C not D, or that, I think that's it. Because I don't need to include this one over here because we've got it here. So that would be it. But we've also got remaining another pattern. So we've got, let's choose a different color. Not A, not C, and not D. This one has not A, not C, but not D, so we ignore that. We ignore this one, but we've got not. In fact, we ignore this one as well because this one doesn't have that pattern. And here we go, not A, not C, and not D, so anything with orange. So I'm going to factorize those out. Not A, not C, and not D. And inside of these, we've got not B. And we've also got B. Now we can simplify this to be 1. That's one side. And what about this? Well, on this part, we can again look at using the common terms inside this bracket. So we're going to have, we've got C, so we've got not C, so we can group the not C's together. By grouping the not C's together, so that's that one and that one, we have not D or D inside a bracket. And then what we can do is also group the C's together, so that one and that one, And inside the brackets we would have D and not D or not D. Alright, now if you simplify this, we're going to have which is fair enough. So we're now going to be left with, if you use multiplication, it's just going to be C. If you use multiplication, it's just going to be C. So we're going to have A, not B, and then we're going to have in brackets, not C, or C. And we know that this would be 1 again. So we have not A, oops. And we know that identity law, we get rid of this ones, so it's just going to be but we're not done. Finally, what we're going to do is we've got common terms here, not A, not A, so I'm going to put them here, not A, and in the brackets we're going to have not B, or not C, not D. And that is as far as we can go in terms of our simplification process. Pause the video, give this question a go yourself first. Okay, so looking at this by itself, it's going to be quite hard to see any patterns, so what we can look for is common terms instead. So we've got not P, not Q, not R, not P, not R, not S, not Q. Okay, so what comes up multiple times? Not P, not R, not S, not P, not R, not S. So that's what we're going to do to start off with. We're going to make that into one. Not P, not R, and not S. And then we're going to take the Q. So that is this bit done. I'm going to OR it with, and on this side we've got P, R, S, P, R, S. And inside of here we've got not Q, so if we simplified this Q and not Q, it's 1, and same with this side, it's 1 multiplied by this will disappear, so it could be left with not P, not R, not S, or P, R, S. Done. We can't go any further than that. Pause the video, give this a go yourself first. Okay. What I'm going to do is I'm going to look at this inner first, and if we look at this, we've actually got distributive law in action. Because if you look at this is basically the A, you could argue this is the B, and this is the C. And what this will equal is the A being put on both sides, so it's going to be something like this. And then we're going to have AC or B, C. Don't know why I've done two brackets there. That was stupid. So if we have a look at this again, we've got A, we've got B, and we've got C. Oh look, distributive law, again we can use. So we're going to have, in essence, if I go to this, no, didn't mean to do that. AC or BC. Now we know that AA just gives us A. Now we can look at common terms. So we've got AC and we've got AC. So AC and we've got B and 1. Or should I say or 1? B or 1, we know, gives us 1. So we've got AC 1. We know that C multiplied by 1 would be, doesn't matter, so it makes us redundant. So our answer is AC. Pause the video, give us a go yourself first. Alright, so if we're going to simplify this, let's start off with this to begin with. Not B and B, as we know, will give us basically 0. We can just erase it, not there anymore. So we can just do oops, didn't mean to do that, don't need that. Okay, so that's my step 1. What next can we do? Well, we've got this situation. In itself. So if we look at that relationship, let me just highlight, we've got this to begin with, where we've got A, B, C. These are different. Each variable here is different. What rule can we use? Distributive. So let's do that. Where we're going to have A, not A, or AB. And we can do the same for the next one. So not CA or not CB. And we can do the same for the next one. A, not B, or AC. What can we do next? Well, let's look at this. A not A is 0. So we can have AB plus CA or CB or AB or AC. Now we've got A as our common terms, so we'll do A, then take the B or not B, and then we can do the same for the next one where we've got A again. So let's do an or here, sorry. Not C or C, and then we're left with not CB. So So if we to simplify that, this would be B or not B, which gives us 1. This gives us 1, so A1 or A1, not CB. And then we just got A or not CB.